All right, welcome back, grade 12s. We are looking at 4.2 and 4.3. We are going to discover a new way to measure angles called radians, and we'll practice a little bit of trigonometry, particularly the cast rule, with this new way of measuring angles, radians. Without further ado, a radian is a special measure. Um, you know what? This angle kind of gets to the idea. It involves the radius of a circle and the arc length of the circle. One radian, by definition, one exact radian, is a certain situation that happens. We take a circle with obviously a radius. The angle measurement that creates one radian is obviously, well, we have one radius here and here, is the exact measurement for which we create an arc length exactly also equal to one radius. You want to imagine one radian being the angle of a pizza slice at which the crust of your pizza slice out here is the same length of the radius of the circle itself. The importance of this is for the following reason. I'm going to play out a little animation here. You can watch it. Yeah, once again, this little arc length is one radius. And this angle is one radian, the new way of measuring angles instead of degrees. It takes about 3.14 radians to go a half circle. I wonder what that 3.14 could mean. And therefore, it would take, well, 2 pi radians to go in a full circle. So here's the new idea. Instead of talking about degrees as a way of arbitrarily measuring the angle of a circle or any sort of angle, our new way of measuring angles is 2 pi. They both represent the same thing. To rotate once completely, we can talk about 360, or why not as a ratio of the circumference of the circle. We know to go in a full circle, the circumference of a circle is 2 pi r. So why don't we just give a sort of percentage of 2 pi that we have in relationship to the circumference of a circle? The real rationale is behind the actual 360. 360 is arbitrary. We, for some reason, decided, hey, we can create a pizza with 360 slices, and that's the best way to measure a circle. And you know what? It was quite effective for a long time. However, to do math, let's say more cleanly, introducing the idea of a radian helps us do certain things a little bit easier. You'll see it a little bit later on. It's going to be a tough transition phase now between us kind of going from degrees to radians, but all the ways we've been working with trigonometry still apply. The way we measure angles have changed. It's like talking about meters to feet. Actually, it's the other way around. We're actually going to a more consistent and kind of better way of measuring angles. But that's it. We're just doing a simple unit conversion. All our trig facts like SOHCAHTOA still is the same. Sine is still the height of a circle, things like that. That's all the same. All right, let's introduce this new language. Let's kind of see how it plays out. Okay, so the first thing we got to do is be comfortable converting from one to the other. Well, we saw that earlier, 2 pi radians was equal to 360. That's the conversion rate. So a single pi is equal to 180. So to determine how many pi radians we are given here, we'll take our degree value, and if we want to get it into radians, we are going to multiply that by pi and divide by 180, the conversion factor, 180 degrees. So we'll take that 30 multiplied by pi over 180, and that's equal to, we can now do some little fractional math here, 1 over 6, so pi over 6. And obviously, if you want, you can grab a calculator. Same idea here. To convert our degree value to radians, we will multiply it by pi over 180. Both 135 and 180 are divisible by 45. If you divide by 45 and divide this by 45, this becomes a 3. That becomes a 4. So we have 3 pi over 4 radians is the equivalent. And 360, well, we saw that in the origin here. Before, to go in a full circle, it was 360. Now for radians, it's 2 pi. So this is equal to 2. convert each of the following into from the radians to degrees. To go the other way around, from radians to degrees, we'll take our radian value and we'll multiply by 180, but divide out the pi. Okay, so let's see that here. 4 pi over 3 will multiply by 180, divide by pi. Pi's cleanly cancel. And the 3 will cancel out with the 180, leaving a 60 behind. 60 times 4 is 240 degrees. The next one, same idea. It's not pi radians because it's just some arbitrary angle. 2.5 rad might be about that big. And we just need to find a degree value for it. So we'll still apply the same kind of idea, multiply by 180 divided by pi. But because we don't really have pi radians to work with, we will actually input the value for pi. 3.14 is good enough. So we have to kind of approximate here, which is okay. Grab a calculator this time. So 2.5 times 180 equals divided by 3.14, excuse me, and that's equal to about 143 degrees. Beautiful. All right, so that is the basics. Us just discovering this new way of measuring angles called radians. Now let's see some trigonometry with it. Now, there were some examples in lesson 2 that I'm kind of skipping here because for the most part, we're just going to see them done in lesson 3. In lesson 3, here we go. Determine the exact value of each of the trigonometric ratios. You can find the exact value for any radian with pi as long as the denominator is 2, 3, 4, or 6. So let's have a look at the first one. Determine the value of sine of 11 pi over 6. Or just to begin here, let's do some side work. Side work number 1 is let's remember our old special triangles in the format of radians. They are now going to be 60 degrees, which is now pi over 3. We had 30 degrees before. That's going to be pi over 6. And we have the 45 degree triangle, which is now pi over 4. Pi over 4. 1 root 2. 1 root 3 and 2. Okay, and now these are our two special triangles, just in the language of radians. All right, let's get some pictures down. Where is this pi, 11 pi over 6? Okay, we used to label our castural kind of x and y axes as 0, 90, 180, 270, back to 360. However, that's all gone now. Let's convert them to their radian counterparts. Still 0. We get pi over 2. We get pi. We get 3 pi over 2. And we have 2 pi. We're going to now try to draw this. Okay, so you can now... one way to kind of imagine this is you want to find a relative number for 11 pi over 6. This is slightly smaller than 2. So you should hopefully predict that, okay, that 11 pi over 6 is going to be about there. If that doesn't work, you may also kind of convert the denominators of all of these kind of labels for the cardinal directions to be over 6 instead, so you have a better idea of where that 11 pi over 6 is. We're going to convert this to, okay, this is 3 pi over 6. Pi is the same as 6 pi over 6. This is 9 pi over 6, and 2 pi is the same as saying 12 pi over 6. So clearly we see this 11 pi over 6 thing. Well, it's going to be between 9 pi over 6 and 12 pi over 6. Let's put down that terminal arm. Okay, there we go. This angle out here is 11 pi over 6, giving us that little angle in there, that related acute angle, our little alpha, is going to be, well, 11 pi over 6 was the outer angle. Well, to make a complete circle is 12 pi over 6. That little alpha is equal to just pi over 6. So we can change our sine ratio here from the principal angle to sine of the acute angle, pi over 6, as long as we also account for our good old friend, the castural. We're doing sine in the C quadrant, so we need a negative sign there. All right. Now we're basically on the home stretch. Now we got to figure out what is the value of sine pi over 6. Well, pi over 6 is sine 30, essentially. But we're going to use that angle pi over 6 here. The opposite side, 1, divided by, oops, not the adjacent, the hypotenuse, 2. So it's still working the same way. Sine of pi over 6 is the opposite over hypotenuse, which was 1 over 2, with a negative sign in front. That's the name of the game. All right, so we're still playing casserole. And by the way, you could still put this in a calculator. If we ask for a diagram, ask you to show your work, this is how you show your work. Okay, well, we're going to rinse and repeat. This is a reciprocal ratio, so it's just going to become 1 over cosine of 5 pi over 3. Let's draw where 5 pi over 3 is. I'll let you try that out at home and justify the following. You will learn that 5 pi over 6 is almost 2 pi. It's going to land here, also in the third quadrant, in the C quadrant, and we'll have an alpha angle of pi over 3. So let's make a little conversion here. So our old 5 pi over 3 becomes 1 over cosine of pi over 3. Because we're in the C quadrant, we're doing cosine, we can leave that as a positive cosine pi over 3. Two more steps here. So what is cosine of pi over 3? Let's go to our pi over 3 triangle. Cosine says to do the adjacent side divided by hypotenuse. So that becomes 1, oh, let me just remove that. It becomes 1 over 2. And what are we doing? The reciprocal of 1 over 2 is 2 over 1. Final answer, 2. Let's do the last one here. Okay. Cotangent of pi over 3. This is between 2 pi over 2 and 2 pi over 4 and 4 pi over 4, which is pi. So it's going to land somewhere here. One more time, if you want, you can actually change up the labels. Instead of doing 0 pi over 2 pi, 3 pi over 2, and 2 pi, you may find it more convenient to label them as denominators over 4. So we can clearly see where is 3 pi over 4. This becomes 2 pi over 4. This becomes 4 pi over 4. Oh, my 3 pi over 4 has to be exactly halfway. And actually, let's kind of go further. That little alpha is also going to be pi over 4. So this cotangent is going to become, first of all, 1 over tan of 3 pi over 4, just to convert the cotangent to tan. Now let's convert to the alpha related acute angle. That becomes tan of pi over 4, just the acute angle. However, we are in a negative quadrant for tan. That's S. So it's going to become a negative. Okay. So, and now we are kind of done. Once again, let's go to pi over 4 triangle. Pi over 4 triangle is down here. Tangent says to do the opposite divided by adjacent. So let's do the following. So we get equals 1 over negative 1 over 1. How fancy. This is just all negative 1. Going on. Okay, state an equivalent expression in terms of the related acute angle, and we'll go from there. Here we go. So we want to find another ratio that is equal to this. In terms of the related acute angle. So if we wanted to, we could actually calculate the value of this right now using casserole, just like we did earlier. However, the spirit of the question is not, but that's not the question, what the question is asking for, to find the value. It said to find a similar expression. Could we find another cosine of another angle that would produce the same result? Okay, so let's just figure out, first of all, where is this 2 pi over 3? You put it down on your little map. 2 pi over 3 is over here. So how else could we produce a ratio with 2 pi over 3 and also match it to cosine of 2 pi over 3? Well, let's kind of put down a little alpha here. Little alpha here is going to be pi over 3 because this is 0. That's pi over here. Pi and 2 pi over 3 make 3 pi over 3, better known as pi. Okay, what else could be equal to that? Well, one way of kind of cheating the system here is to measure the same terminal arm in a different way. One way to go about this is a coterminal way. It's a little bit of a cheap shot, but it works. Okay, we can go with an extra rotation. How do we add an extra rotation in radians? Before, to find coterminal, it used to be plus or minus 360 degrees. a full rotation, either in the positive or negative direction. This time, we can do the same idea with the plus or minus 2 pi. Let's find a coterminal angle to 2 pi over 3. 2 pi over 3, let's say we're adding an extra rotation like I drew here, so we can add 2 pi to it. That becomes 2 pi over 3 plus 6 pi over 3, better known as 8 pi over 3. Therefore, another way of getting the same value as cosine 2 pi over 3, let me write that out here, cosine of 2 pi over 3 would be equal to cosine of 8 pi over 3. Try on your calculators, see that they are the same result. Okay, the true spirit of this question, however, was to not use the same arm. We need to find another location on this little map where we would find a cosine of 2 pi over 3 having the same value. To do that, let's first recognize if we do cosine in this quadrant, we're going to get a negative value. Think about where else we could find a spot for a terminal arm to produce a negative value for cosine. It has to be in the t quadrant. And now, how do we get the same value? Well, what's the relationship between all this? What did we learn? A primary angle can be converted to its related acute angle if they're in the same kind of quadrant that would produce the same sign. So if we keep that alpha angle the same as pi over 3, this location, this terminal arm, will also produce the same value as cosine 2 pi over 3. Okay, let's draw a separate diagram and do it again. So we know that this one out here with pi over 3 is another location that will give us the right answer. Well, it's our job now to find what is the measure of that angle. So how big is this angle out here? Well, to get there, we need to go to pi first and then go an extra pi over 3. So let's find out what that is. Pi over 3. This becomes 3 pi over 3 plus pi over 3, which is 4 pi over 3. Another ratio that would give us the same result is cosine of 4 pi over 3. All right, one more time with the tangent. So for tangent 7 pi over 6, let's figure out where it lives. 7 pi over 6 is over here. 7 pi over 6. And let's also label that little alpha. Alpha is equal to pi over 6. We ask ourselves, hey, okay, tangent in this quadrant, it's in the t quadrant. It would also produce a positive result if we were in the a quadrant with the same alpha angle. So here's another tan ratio, tan of pi over 6, that would produce the same result as the original ratio. We went the casserole route. If you wanted to go let's say, the coterminal route here, maybe we measure this terminal arm in a negative fashion. This would also be equal to, so this is pi over 6 here. This would be a rotation of negative 5 pi over 6. Once again, because this would be negative pi, this would be 0, measuring negatively. Tan of negative 5 pi over 6 would also work to create the same equivalent expression as the original ratio. Okay, keep going. These ones here, you're just going to grab a calculator. If we do not have a denominator of 2, 3, 4, or 6, once the ratio was reduced, we're out of luck. We grab a calculator and we go from there. So 1 over cosine of pi over 36. Honestly, once again, just grab a calculator. We're going to have 1 divided by make sure, oh, by the way, make sure your calculator's in radian mode. You may have to do some research in terms of how to put your calculator in radian mode. Do I remember how to put mine in radian mode? Yes, I do. Okay, cool. So we are doing 1 divided by the cosine of, also knowing where your calculator has a pi button will help. Okay. I am getting a final answer of 1.0, says to 4 decimal places, so 0038. This becomes 1 over tan of 16 pi over 45. So 1 divided by tan of 16 pi divided by 45 is 0.4877. No point copying this down. You might as well try. This is an exercise in, do you know how to use your calculator? 2 pi over 5. Okay. One more time. 1 divided by sine of 2 pi button divided by 5 is equal to 1.0515. Beautiful. If we're working on a domain of negative pi to 2 pi, determine the values of a that satisfy the relations. Well, equations. Here we go. Even before we get started here, look at what we're given. Okay. Notice a couple things. Here we're positive. Here we're negative. Let's go one at a time. But look at these numbers. They come from a specific triangle. We've seen this before. Okay, so let's familiarize ourselves with that 1 root 3 2 triangle, which has angles of pi over 3, which is the 60-degree angle, but we don't say that anymore, and 30-degree angle, or pi over 6. Okay, so first of all, we are looking at sine, which produces opposite over hypotenuse. Which angle will give us an opposite side of root 3 and a the hypotenuse has to be 2. Which side gives us the opposite side of root 3? Well, it's pi over 3. So right now, even without a calculator, we have solved for alpha. The alpha that makes this work is that pi over 3. Okay, from here, what do we do? Well, we're looking for sine to produce a positive result. The locations where sine becomes positive are in the A and the S quadrants. And we know now from our analysis of the numbers that alpha angle was pi over 3. So this angle here is pi over 3, and so is this angle. Okay, so let's write them down. This is theta 1. This is theta 2. Theta 1, how do we go from 0 to there? Well, we go directly there. That's equal to alpha, pi over 3. Theta 2, it's a little bit more interesting. To land at that terminal arm, we need to start at 0 and go to here. Unfortunately, we can't get there directly. We have to first rotate a little too much. We rotate all the way over to pi, and then we go backwards a little bit. And we take away our alpha, which is equal to pi minus pi over 3. I'm going to speed up the math here a little bit. Try this out. You will eventually find that's equal to 2 pi over 3. And those are the two answers we're going to get. I'm going to be a little silly and not justify anything. We're just going to say we're going to move on to the next question, because that question is done. However, the next question has a little twist where there's a little extra work to be done. Okay, so we have secant A is equal to this. Well, we can't really work with secant. We gotta swap things out here. So that's cosine of A, 1 over cosine of A is equal to negative 2 over root 3. But we should not work with 1 over cosine. Let's reciprocate both sides. If you have a single fraction on each side, you're allowed to take the reciprocal of both sides. Here we go. So that becomes cosine of A is equal to negative root 3 over 2. We see two things. Well, doing the same analysis we did earlier, when do we get an adjacent side of root 3 and a hypotenuse of 2? We're talking about the angle of pi over 6. So our little alpha is equal to pi over 6. Okay. And the secondary analysis we need to do was the sine. We want a cosine to produce a negative angle. Okay, let's start drawing this out. So to get a negative cosine, we're talking about a terminal arm on the left side. There we go. And we discovered that the alpha angles were pi over 6 and pi over 6. We can now label both of those as theta 1 and theta 2. Our theta 1 answer, I shouldn't have called them theta, I'm so sorry. We used the letter A. Let's call them A1 and A2. A1, answer 1, and answer 2. To get to A1, we are going to rotate to the closest x-axis and then move by alpha. So that's equal to pi minus pi over 6, which is equal to 5 pi over 6. To get to A2, we're still going to rotate by pi, but we need to rotate further. So we're going to rotate by pi and add a pi over 6, giving us 7 pi over 6. Now, this is exactly what we did in the previous question. However, in this particular example, we are not done. Pause the video, think about how these two examples are different, and what in the original question we read, but I kind of glossed over, is important here, but not in example A. Oh, example A. Here we go. Notice how we considered all answers in a positive circle starting from 0, because it said, hey, consider all angles for a positive rotation for one complete circle. We did that. But we kind of ignored. You also want to consider all possible answers for a negative half rotation. In the previous example, if we try to go a negative half pi, we encounter no terminal arms. So there are no answers more to consider in that domain. However, there is one more answer to consider if we go a negative pi rotation. There's an A3, which is coterminal with A2. How do we make this happen? So, well, we're just measuring the angles in a negative way. How do we get there? A3 is us traveling to negative pi, but we've traveled too far. How do we undo a little bit of negative pi? Now, we have to be a little careful here. We always treated alpha as positive. That's the way I've treated it anyway. Look at the action and the way alpha is going. This alpha is rotating in the positive direction. Or the way you want to imagine it is that we're opposing this rotation of negative pi. We're going to add a pi over 6. If we subtracted a pi over 6, we're saying rotate further in the negative direction. That would find a coterminal angle with a 1. Okay, so let's actually wrap this up. That's negative 5 pi over 6, giving us 3 answers for terminal arms that produce the ratio of secant A equals to negative 2 over. All right, determine the primary trig ratios for the angle of this. All right, when we do multiple trig ratios, well, first let's just draw that thing in. This is negative 2 pi over 3. It's actually pretty prudent for us to draw a right angle triangle. Well, this whole angle out here was that negative 2 pi over 3. It's bigger than negative pi over 2, but not as big as negative pi, which is equal to negative 3 pi over 2. Whoa, what was that? Negative 3 pi over 3. So we have a little leftover alpha angle equal to pi over 3. Once again, I do not put signage on alpha. I just think about how it moves. So pi over 3 here tells us, wait a second, we have a special triangle with pi over 3. Its opposite side is root 3. Its adjacent side is 1. Its hypotenuse is 2. We are now ready to do SOHCAHTOA with this. We have our adjacent side, our opposite side, and our radius hypotenuse. Beautiful. That's it. We're done. Sine of pi over 3 is equal to, negative 2 pi over 3 is equal to opposite. So we're still doing opposite hypotenuse. Opposite root 3 divided by 2. However, be careful. We are playing fast and loose because we are in the t quadrant. So that's going to be a negative root 3 over 2. Rinse and repeat cosine of negative 2 pi over 3. That's equal to adjacent over hypotenuse, which is our adjacent side of 1 divided by our hypotenuse 2. We're still in that t quadrant. So put a negative on that. And lastly, we are doing the tan of negative 2 pi over 3, which is equal to the adjacent, opposite over adjacent, TOA, which is opposite root 3 divided by that adjacent 1. So our final answer is just root 3. We're in the t quadrant, so that's positive. We are done. By the way, the reason why we do cast rule at all is because of the signage on our x and y's. By the way, if you saw this as a negative 1, and if you saw this as a negative root 3, those are actually better labels. And you would notice that it already encodes which ones are going to be positive or negative. We have a negative sign value there because our y value is negative. We have a negative cosine value there because the x value is negative. We have a positive tan value because the ratio between x and y is positive. Okay. Last example, A and B. Let's go. The terminal arm of an angle in standard position passes through each of the following points. Determine the radian values of the angle to the nearest 100, so 2 decimal places. Right, let's draw a quick sketch of what this thing looks like. We are given this location is negative 7, 8, so about there. All right, well, we always need to see a right angle triangle with these sorts of things, so let's label it. So we have 7 out here, we have 8 out here. We want to know what is this theta. All right. Step 1, let's figure out this alpha. Look at what you're given. We're given the opposite and adjacent sides here. So we're going to do tan of alpha is equal to opposite side 8 divided by 7. Now, alpha will be equal to tan negative 1 of 8 over 7. What is the answer to that? Okay, so how many radians are you? Inverse tan negative 1 of 8 divided by 7 is equal to 0.86. Now, this is not a clean angle answer. There's no pi's involved. When this happens, well, you used to put degrees, but it's not degrees. We have to call this radians. Okay, well, we need to figure out what this theta was, however. This was pi out here. So theta is equal to pi minus alpha. Why? Because it's this measure over here with the alpha removed. Okay, so we're going to take 3.14 and take away 0.86. Which is equal to 3.14 pi take away. If you want to keep more decimal places on pi, you absolutely can. And that's equal to 2.28. And now to the last example. Same idea. We are going to, forgot to label this as red. We are going to put down a little terminal arm here for -5, -2. -5 is over here. -2 is about there. We'll draw that out there. We will start like we did before by looking for that alpha. -5, -2. Tan alpha, opposite of 2, adjacent to 5. Alpha will be tan inverse of 2 over 5. So let's grab a calculator. Second tan, 2 divided by 5 equals. Alpha is 0.38. And now we got to think about how do we measure that angle to that terminal arm. Starting from 0, how do we get there? Our theta is equal to pi, but we have to go a little bit further than just half a circle. We have to add our alpha here, which is equal to 3.14 plus 0.38. Final answer is 3.52 radians. Okay, welcome to Radians.